This is a deep-sea mining robot. It's designed almost like a giant's pool cleaner to suck up potato-sized rocks on the seabed. These rocks, known as nodules, contain enough battery metals to power our green energy revolution, and can be harvested in a seemingly far less harmful way than getting the same materials on land. However, there is one major factor standing in the way of this giant metallic beast: the gummy squirrel. This recently discovered gelatinous sea cucumber relies on these nodules to survive. Removal of their habitat could spell disaster for the creature and catastrophic collapse of the wider ecosystem that relies on it. This is the heart of the deep-sea mining dilemma.
150 years ago, people thought there was really no life in our deep seas. It would be too dark, too cold, not enough food, etc. 19th century, the voyage of the HMS Challenger, that proved that wrong effectively.
Adrian Glover is a deep-sea biologist from London's Natural History Museum.
People found quite a diverse range of organisms living in the deep sea: little worms, small starfish, little shrimp-like crustacea, and mollusks, like all clams, gastropod snails. By and large, most of our world is deep ocean, and most of that is mud with worms.
While these creatures might seem like insignificant, distant alien species to some, we don't yet know the impacts they have on the wider ecosystem or what scientific or medical discoveries await us in the study of these animals. For these reasons, the seabed has been protected by international agreements and law up until now. Earlier this year, President Trump signed a decree allowing commercial mining of the seabed, which has created a new round of panic in some circles and international condemnation from the likes of China. The agreements, such as the United Nations Convention on the Law of the Sea, were designed to ensure our marine environments are preserved for future generations. As part of that, the International Seabed Authority was established to regulate the ocean floor in international waters. Geologist Ulrich Schwarz-Schampera from this organization explains.
It regulates the access and also basically the financial potential exploitation. It refers to the area with a capital A, which is the area outside national jurisdiction. It used to be open land. Now it's the common heritage of humankind. It's how it's defined in the UN Convention. And that's regulated. Who can do exploration for marine minerals and under what conditions?
However, many see these laws as outdated, slow to develop workable regulation, or simply wrong when it comes to planetary impact as a whole. When most people think of mining, they see deep drilling, giant pits, and use of blunt, unsubtle tools like explosives. However, deep-sea mining works more like a vacuum, sucking up these nodules off the top of the seabed. Gerard Barron from Canadian-based The Metals Company explains.
Fortunately, they lie unattached. It's like golf balls on a driving range. And so with our partner Allseas, we developed a robot that sits on the ocean floor and fires a jet of water through a cylinder nozzle, which basically creates an inverse pressure and lifts the nodule into the collector, and we then separate out the sediment and, using water as the vertical transport system, send it up to the production vessel in our riser. They then get offloaded to a transport vessel where they move to shore for processing and refining. So we're just fortunate how this resource is formed. Loose rocks sitting on the seafloor, no drilling, no digging, and it means that we can be very low impact as we go about collecting these rocks.
Mining at 4,000 meters is like operating on Mars. The pressure could crush a submarine, temperatures hover near freezing, and there's zero light. Engineers have developed a three-part system straight out of sci-fi. A tracked robot crawls over the seabed using hydraulics to harvest the nodules. The riser, which pumps the nodules, stretches 4 kilometers to the surface. However, the challenge is to prevent sediment plumes from entering the water column. 200 tons of slurry are pumped to the surface each hour, and any leaks could be disastrous. Once the nodules are separated on the surface, the wastewater has to be discharged to an agreed depth of 1,500 meters. So, what's so special about these nodules, and why is there so much interest in developing new technologies to harvest this material over traditional methods?
For the last 14 years, we've been focused on understanding this very large resource of polymetallic nodules, like the one in my hand. And they sit on the ocean floor. They form through slow precipitation of the metals that are found in our oceans, the sediment in our oceans. The area we're focused on is about 1,100 miles southwest of San Diego, and it's an area known as the Clarion-Clipperton Zone. It was discovered way back in the 1870s by the British, who sailed around the world, curious to know what was on the bottom of the ocean floor. And the reason why this area is of particular interest is because these nodules contain very high grades of nickel and copper.
Let's talk about critical minerals. These are essential materials for modern technology. Think lithium for batteries, cobalt for electronics, and nickel for renewable energy systems. They're crucial for everything from smartphones to electric vehicles. Salim Ali is the Geography Department head at the University of Delaware.
So in the work that I'm doing, and particularly the case that's made for deep sea mining by many people, is that these are minerals which are needed for the clean energy transition. So minerals which are needed for infrastructure such as solar panels and wind turbine magnets, battery storage devices which are needed for smart grids and the like.
Unlike gold or oil, these aren't precious for their monetary value. They're indispensable for national security and green technology. A single Tesla Model S battery pack requires approximately 12 kilograms of nickel and 4.5 kilos of manganese. Your smartphone contains at least 30 different metals, including cobalt, which prevents battery fires. Here's why engineers are desperate for new sources. The International Energy Agency projects demand for these minerals will skyrocket 400 to 600% by 2040. But our current supply chains are fragile, ethically fraught, and environmentally devastating.
In the case of China, there are two ways in which they primarily mine rare earths. One is they're a byproduct of an iron ore mine in Inner Mongolia, and they've been able to extract it from hard rock deposit. But you can also have rare earths extracted from what they call ionic clays, where you have sediments which are washed into rivers and they have accumulated certain amounts of these materials. Just like with gold, you have both hard rock gold mining as well as gold panning, which happens in rivers. You also have other techniques which have been developed now. We call in situ leaching, for example, where you inject chemicals into an ore deposit and that dissolves some of those metals, and then you extract the solution and then you bring the metals out from that. So there are many different ways in which you mine. There are techniques also then to further refine it. So yeah, it's a very involved and complicated set of steps that are needed.
Mining the seabed can disrupt marine ecosystems, destroy habitats, and release toxic substances into the environment. It's a delicate balance between resource extraction and environmental preservation. However, compared to mining in areas such as the rainforest, there is 300 times less biomass affected. Undersea mining operations have an estimated 90% lower emissions than mining on land. And there is an undoubted improvement by doing away with such things as child labor in the Congolese cobalt mines.
There are some fish down there, but the good news is they swim away. But we're talking mainly about single-cell organisms living in the sediment. And we have, on average, less than 10 grams of life, call it biomass, per square meter. And more than 80% of that is bacteria living in the sediment. It doesn't mean that life isn't important. And for the last 14 years, we've spent hundreds of millions of dollars in independent quality ocean research to understand what will the impacts be. And there are some organisms that depend on the nodules. They are obligates. And of course, when we pick up that nodule and move them away, that's probably a bad day for those guys. But a lot of the other life sustains. And in fact, there is some evidence that we actually increase productivity because it's such a low energy environment. There's no food down there. It all gets eaten as it falls down through the water column. And so what we found is that When we went back there a year later, there was actually a lot of activity right next to where our tracks went through, which you would think would be the area of highest impact. But actually what we saw was more life coming into that area because critters are going, food, we want to come in where there's food.
However, some argue that mining could be a biodiversity time bomb. 90% of species in mining zones are undiscovered, and the nodules have taken millions of years to form. There is also a worry that disturbing the seafloor could release stored CO2 and disrupt carbon sequestration. Also, the sediment plumes caused by disturbing the seabed could have an effect on the ocean thousands of kilometers beyond the mining sites.
Interestingly enough, in a study published in March in Nature on the impacts of a 45-year-old mining test that took place in 1979, amazingly enough, you could still see the impact geophysically in terms of the seabed. It looked as fresh as if it was made yesterday. But of course, biologically has started to recover. So for the smaller animals, these little polychaete worms, the small crustacea, the snails, you couldn't actually detect a residual impact anymore. For the larger organisms, typically living on the nodules, obviously they haven't recovered because the nodules are no longer there.
Now, how does seabed mining compare to traditional land mining?
We compared the waste generated by terrestrial mining and the waste generated by deep sea mining, and the deep sea mining has much less waste generation. Whereas on land, you have these massive tailings dams that come out, but the waste has to be stored, and that in itself can be a hazard. In Hungary, you've had a disaster in the Danube some years ago. You've had one in Brazil, two in Brazil actually in the last decade, which were pretty severe. So that's the attractive feature of these nodules. The other two types of deep sea mining are what we call seamount cobalt-rich crusts. And the third is the one where you have hydrothermal vents with sulfides. And those two are much more, I think, risky. They're more problematic because for the polymetallic nodules, you're talking about very deep water. So you don't have as much interference with commercial fisheries.
While both have environmental consequences, seabed mining can be less visible but potentially more damaging to marine life. So, what have these international regulation bodies actually been doing, and what is the impact of President Trump's decree?
The first attempts to write the exploitation regulation started actually in the 1990s, right? The approval of a mine on land, the average takes 18.7 years. It's a complicated process when it comes to administration, when it comes to regulation and so on. And many agencies are involved. They have to assess what's planned. This takes time. For many, it takes too much time. Yes, right? For many others, it's not taking enough time.
This inability to come to a definitive agreement brings us to the bombshell that split the ocean in two. On April 24, 2025, President Trump signed an executive order bypassing decades of international consensus. The order directed US agencies to expedite the issuance of commercial deep-sea mining licenses in international waters. Essentially, this declared America's right to mine the ocean floor without waiting for global regulations.
If we wind our clock back to the 1970s, this industry almost got started, and America dominated this industry. In fact, they hired Howard Hughes, who was leading the charge with the Glomar Explorer. And back then, it was true engineering. Like, these systems had never been built. We at least have the advantage of the burgeoning oil and gas industry offshore and the pipeline and trench digging and so on. But back then it was like first of its type. And the US government put in place regulations, both exploration and call it mining regulations, they're called commercial recovery permits, to allow the development of this industry. Now, at the same time, a number of countries, now totaling 169, signed a treaty known as UNCLOS, which said, look, when it comes to the metals on the seafloor, we signatory countries will agree to this set of rules. But the United States never agreed to that treaty, and so they have their own rules. And it is those rules that we now depend on. And unfortunately for those 169 member countries, the organization called the International Seabed Authority has not done a very good job of agreeing those rules. And they were set up in 1994. The exploration regulations came about in 2001, but here we are today, 2025, and still no rules.
The International Seabed Authority Council of 37 countries condemned the move by the United States as neo-colonial resource grabbing. But why such fierce opposition?
If you took the nodules away from an area, like a commercial scale mine might be 10,000 square kilometers, something like that, it will remain permanently altered for a very long time, and potentially permanently. In the same way, I mean, it's not wildly different from when you remove forest to put in a monoculture of agriculture. Hundreds of years to recover, and it probably never will. I mean, it might be that some of the species have gone extinct anyway, so they'll never come back. Firstly, it has to decide whether that's acceptable or not. And then secondly, how you minimize those impacts. And protect areas so they can be reservoirs of that biodiversity. And that's the things that science can help with.
Miners like the metals company claim they can minimize the risks.
In 2022, we ran a commercial trial. We had the hidden gem at sea. We had another science research vessel filled with scientists observing the impacts. We did a very thorough survey of the area before we started. We then surveyed it while we were in production. We had like 50 assets in the water monitoring everything in the midwater and the benthic zone. And we then went back there and did the same piece of work immediately after we'd finished the commercial harvesting. We then went back a year later to see how quickly the area had recovered. And, the signs are super encouraging. Life was blossoming down there. And we find that it's that independent scientific data that we need to depend on, because of course Greenpeace will speculate what the potential impacts are, but they don't spend any money on research. They just spend money complaining and protesting.
However, some oceanographers fervently disagree, while others say the jury is still out as more research is needed. As the International Seabed Authority discusses, private companies are preparing to begin exploiting seabed minerals. The metals company accepts working under US regulations cited by NOAA, the National Oceanic and Atmospheric Administration, and the Department of Commerce. However, it acknowledges that there will be an impact on the seabed, but it must be taken into context.
We're entering a period of trade-offs, and we ourselves do not argue that we are zero impact. We're just saying that our impacts are a tiny fraction compared to the impacts of land-based activity. So I think it depends what type of resource we're talking about on land. And of course, if you look at Australia or Canada, where most of their mines are located in very sparsely populated areas where there isn't much of an alternative use for that area. So that's fantastic. But then if you go to the areas on the tropical rainforest belt and you see what the alternative uses for that landscape is, they're tremendous. Firstly, there's people living amongst them. There's an enormous amount of biodiversity amongst them as well. They're massive sequesters of carbon. And then, of course, once you dig up the material, the range of impacts continue, because a lot of the tailings or the treatment of those materials finds their way into waterways, freshwater systems, oceans, where their knock-on impact is even greater. We have to be sensible and say, what are our set of impacts? How do they compare to the known set of impacts on land-based? And then which one do we want? And that's the job for the regulator.
While America goes solo, the rest of the world is scrambling to finalize rules at the International Seabed Authority. Their deadline? December 2025. But negotiations are gridlocked over 3 explosive issues. A couple of dozen countries are seeking a moratorium until the full impact of seabed mining is better understood. They also want to know how much nodule coverage will remain after the mining is completed. The current draft suggests 15%. And if mining proceeds, who will benefit from international waters bounty? Should there be a royalty to create what has been called a seabed sustainability fund? So where does this leave us? We need critical minerals to decarbonize, but seabed mining risks possible catastrophic unknowns. Unfortunately, without an international agreement, the seabed could become an open house quicker than we realize.
As far as the deep sea is concerned, I think now with President Trump and the approach that he has taken, unfortunately, I don't see any reason why people won't want to go through the ISA. if the world's most powerful economy is saying we just don't want to play ball with these people because the environmentalists are such obstructionists and they just want a level of risk which is unrealistic, and then we are just going to go and do it ourselves. And if the United States is going to do that, then China, which is the second largest economy, will say, of course, why not? And giving them credit that they were the ones who did want to play by the rules. The US did not ratify the Law of the Sea Convention. They would attend the ISA meetings as non-parties. And the US, under Biden, was willing to engage with the ISA. But now it's like, they're just fed up.
Critical minerals are essential, but how we get them and at what cost will define the next phase of engineering and geopolitics. This isn't just about gummy squirrels or battery percentages, it's about who we are as builders. Will we be the generation that saved the climate by destroying the deep, or the one that engineered a more innovative way? The ocean is listening.